This video lesson demonstrates how to find factors of numbers as well as greatest common factors of number pairs and number sets. This lesson works by having different slides with examples, explanations, and other ways to factor either a set or a pair of numbers. It also shows how to prime factor a number. You want to make sure that anything you see in red or anything that is instructed to you to write down, you put in your notes section. And any blue vocabulary words that you see should go in your 3-column notes vocabulary section. And of course, it's very important that you ask any questions that you may have while you watch the video lesson. The purpose of this video lesson, and by the end of the video lesson, you will be able to find all the factors of a number. You will also be able to express a number as the product of its prime factors, so you will be able to prime factor a number, and you'll be able to find the greatest common factor for a pair or a set of numbers. Please use your Go Math or Springboard workbook to define these vocabulary words in your 3-column vocabulary section. Factor, greatest common factor, prime number, prime factorization, factor tree. You may pause the video at this time so that you may do that. This is an example of how to write or find the factors of a number. You're going to want to write everything in this example that you see in red. Let's start with the number 6. The number 6 has 4 factors, and you should have defined the word factor in your 3-column vocabulary section. So you should know that a factor is a number that you multiply by another number to get a product. The numbers we can multiply together to get 6 are 1 times 6 and 2 times 3. Those 4 numbers are the factors of 6 because 1 times 6 is 6 and 2 times 3 is 6. So we can say that 1, 2, 3, and 6 are factors of 6. What about common factors? Now we're going to look at common factors. Instead of just listing the factors for one number, what if we have 2? That means we're going to be looking for a factor that are in both lists. So anytime you are asked to find common factors, you want to list the factors of each number individually and then compare the lists. So we have the factors of 6, which we just did, 1 times 6, 2 times 3. And now we want to list the factors of 8. So what can I multiply together to get 8? Well, I can multiply 1 times 8, and I can multiply 2 times 4. Once I have those factors, then I can compare the lists. There is one common factor on those lists, which is the number 2. And I know that you're probably looking at those lists and saying, wait, the number 1 is on both of those lists as well. However, when you are talking about finding common factors, we don't include 1. 1 is never the answer because it is a factor of every single number. So if you have 2 numbers and you ask, well, what are the common factors? Every single pair of numbers are going to use the number 1. So that makes it kind of silly. So we do not include the number 1. So we would say here that the numbers 6 and 8 have 1 common factor, and that is the number 2. What if we have two numbers that have more than one common factor? So let's take the numbers 28 and 44 here. These numbers have more than one common factor. In order to find the greatest common factor, which if you defined it in your vocabulary section, as you were instructed to do, you would know that it is the number with the greatest value on both or all of the factor lists for a pair or set of numbers. So the first thing we have to do is we have to find the factors of each number. So when we list the factors of 28, we think, what are the numbers I can multiply together and have 28 be the product? Well, 1 times 28 is 28. 2 times 14 is 28. 4 times 7 is 28, and there are no other factors. And when you're listing these factors, the easiest thing to do, not the only thing, but the easiest thing to do is to just start 1 times what, 2 times what. Here I would say 3. 3 times what is 28? Well, nothing. There's no whole number that I can multiply 3 by to get 28, so that's why 3 is not on my list. And then 4 times what? 5 times what? Well, nothing times 5. What about 6? 6 times what? Well, nothing times 6. And then what about 7? Oh, it's 7 times 4. Once I hit a number that I'm then repeating, I don't need to go on. So I don't need to ask 8 times what or 9 times what, because I've already gotten to the repeating number. Now we have the factors of 44. So 1 times what? That's 44. 2 times what? That's 22. 3 times what? Well, nothing. 3 does not go in evenly. You can't evenly divide 44 by 3, so there's no factors there. 4 times what? 11. 5 times what? Nothing. 6 times what? Nothing. 7 times what? Nothing. 8 times what? Nothing. 9 times what? Nothing. 10 times what? Nothing. And then we're to 11, and so now we can stop. Once we have the lists of the factors for each number, then we can compare those lists and write down the common factors. Which ones are on both lists? Well, if I look at my two lists, I see the number 2 here and here, and I see the number 4 here and here. So the common factors are 2 and 4. Remember, we are not counting the number 1 because that is on every single factor list, and so it doesn't make a whole lot of sense. Once we have the common factors listed, then we can identify the greatest common factor. And this is the number on the common factor list that has the greatest value. So of 2 and 4, 4 has the greatest value. Therefore, it is the greatest common factor of 28 and 44. Now we're going to look at example 2 of finding the greatest common factor. So let's start with the numbers 30 and 50. And to find the greatest common factor, first we need the factors of each number. So we're going to list the factors of 30. So the factors of 30, I would start at 1. 1 times what? 2 times what? 3 times what? And continue until I hit my repeated number. So 1 times 30, 2 times 15, 3 times 10, 4 times nothing, 5 times 6, and then 6, I've repeated that so I can stop. Once I have my factors of 30, I then want my factors of 50. So I will do the same process. 1 times what? 2 times what? 3 times what? 4 times what? Until I hit my repeated number. So 1 times 50, 2 times 25, 3 times nothing, 4 times nothing, 5 times 10, 6 times nothing, 7 times nothing, 8 times nothing, 9 times nothing, and then I get to 10, which I've already used, so I can stop. Once I have my individual factors for each individual number, then I can list the common factors. Now, once you've already listed your factors, you are allowed or can make the choice to just circle the common factors, or you can rewrite them in a list. So if I look at my two factor lists, I see the number 2 on both lists, and I see the number 10 on both lists, and I also see the number 5 on both lists. I don't see, and we don't count 1, but I don't see 30 on both lists. I don't see 15 on the other list. I don't see 3 on the other list. I don't see 6 on the other list. 50 isn't on that first list, and 25 isn't on the first list. So my common factors are 2, 5, and 10. And once I have the common factors listed, then I look at that list, or look at the circled numbers, and I identify the number on that shared common factor list that is the largest value, which here, of course, is the number 10. So here 10 is the greatest common factor. You may remember learning about prime numbers in a different grade, but for those of you who don't know what they are or don't remember, a prime number, which you should have defined in your vocabulary section, is a number that has exactly 2 factors. The number 1 and itself. There are only 2 whole numbers you can multiply together to get your number as a product, and that's 1 times the number. That means that the number 0 and the number 1 are not prime numbers, because 0 doesn't have really factors, because anything you multiply by 0 is 0, so that doesn't make any sense. But then 1 times 1 only has 1 factor, so 1 is not a prime number, and that's very important that you remember that, because 1 is not a prime number. So let's take a look at an example. The number 7 is a prime number. How do I know that the number 7 is a prime number? Well, the only 2 whole numbers I can multiply together, the only 2 positive whole numbers that I can multiply together to get the number 7 are the numbers 1 and 7. Because there are no other whole positive numbers that I can multiply together and get 7 as the product, 7 is a prime number. What we're going to do now is we are going to prime factor a number. And what this means, which again, if you did what you were supposed to do and defined prime factorization in your vocabulary section, you will know this. But what we're going to do is we're going to express a number in terms of its prime factors, or as the product of its prime factors. So let's start with the number 12. Let's say we have the number 12 and we want to express it as the product of its prime factors. Well, if I have the number 12, I can list the factors of 12. I know 1 times 12 is 12. I know 2 times 6 is 12. And I know 3 times 4 is 12. Now, I don't want to use the number 1 because 1 is not a prime number. And I know 12 is not a prime number because it has more than 1 factor, or more than 2 factors. So 12 is not going to be included. That leaves me with 2, and 2 times 6, and 3 times 4. Now, I can pick whichever one I want here. I'm going to go ahead and start with the 2 times 6. 2 is a prime number because it only has 2 factors. I can only do 2 times 1 to get 2. But 6 is not a prime number. What I need to do then is I need to rewrite 6 with its factors. So the factors of 6 are 1 and 6, or 2 times 3. If I look at 2 times 3, 2 is a prime number, and 3 is a prime number. So instead of writing 2 times 6, what I can do is I can write 2 times, and then instead of 6, I can write the factors of 6, so 2 times 3. And then I have a prime number, a prime number, a prime number. And if I multiply 2 times 2 times 3, that gives me 12. 2 times 2 is 4, 4 times 3 is 12. So the prime factorization of 12 is 2 times 2 times 3, because all 3 of those numbers are prime, and if I multiply them together, the product is 12. That is how to prime factor a number, and that is the prime factorization of 12. Prime factoring numbers in the manner which was in example 1 can get to be fairly messy and difficult to follow. So what we use usually with prime factoring is something called a factor tree. So we're going to use a factor tree to express the number 42 as a product of its prime factors. So I want the factors of 42. So the first thing I'm going to do is I'm going to list the factors of 42. That's really what you should do. Now, if you know the factors of a number, then you don't have to list them all out, but some people find this helpful. So 1 times 42, 2 times 21, 3 times 14, 4 times nothing, 5 times nothing, 6 times 7. So I definitely don't want to use the 1 and the 42, but I can pick any other factor pair I'd like. So I'm going to do 2 times 21. Okay, so I'm going to rewrite my number, 42, and I'm going to use these little branches here, and I'm going to say, look, if I do, or the little caret, some people call it the caret, but since it's a factor tree, I'm going to call them branches. We have 2 times 21. Now, 2 is a prime number, so I'm going to go ahead and circle that. But then I'm going to use another caret, or another set of branches, to rewrite 21 as its factors. And I know 3 times 7 is 21. Well, 3 is prime, and 7 is prime. And so now I have all numbers that are prime factors. So the prime factorization of 42 is 2 times 3 times 7. That is how to prime factor a number in a more organized way. We're going to do one more example with a factor tree. So the factor tree is going to help us express 72 as the product of its prime factors. So I first want to list out some factors of 72. I know I can do 1 times 72. I also know I'm not going to use that one. I can do 2 times 36. I can do 3 times 24. I can do 4. Let's see, does 4 work? Yes, it does. 4 times 18. Not 18, 17. Nope, 18. It's 18. There we go. Not 5 and 6. I know 6 is a factor because 2 and 3 are also factors, and that's one of the divisibility rules. So I know that 6 must be a factor because 2 and 3 are factors. And this is going to be 16, I believe. Nope, it's going to be 12. I knew that. Sorry. And 7, no, but 8 times 9 I know is 72. So again, you don't have to list all of these. I would just go ahead and start with 8 times 9 because when I say 72, those are the two factors I think of. But if it's going to help you, you can list the factors out. So I'm going to just go ahead and use 8 times 9. So again, if I saw this problem as just 72, use a factor tree to prime factor 72, I would say, look, I know that 8 times 9 is 72. Now 8 is not a prime number. It has more than 2 factors. So I need to rewrite this as a product of its factors. And 2 is prime, but 4 is not. So I need to write 4 as a product of its factors. And 2 is prime, so I then am done with this side. 9 is not prime either, so I need to rewrite 9 as the product of its factors, and 3 is prime. So I now have no more composite numbers. I have only primes. And composite, if you remember from perhaps a different year, is when numbers have more than 2 factors. So the prime factorization of 72 is 2 times 2 times 2 times 3 times 3. Sometimes we don't have just two numbers, sometimes we have more than two. And so what we are going to do now is look at an example where we are finding the greatest common factor of a number set instead of just two numbers. And the process here is the same. The only difference is when you are finding your common factors, or the factors on those common factor lists, instead of only two lists, you're going to have however many lists that you have numbers. In this example, we are going to look at a set of three numbers. But just like with a pair of numbers, the first thing we need before we can find the greatest common factor is the factors of each individual number. So first I'm going to list the factors of 25. 1 times 25 is 25. I know nothing times 2 because 25 is not even. Nothing times 3 and nothing times 4. But then I also know 5 times 5 is 25. And then I've repeated my number, so I'm done. Now I'm going to move on to 75. I know 1 times 75. 2 is not going to work because it's not even. 3 times 25, 4 does not work, 5 times 15, 6 times nothing, 7 times nothing, 8 times nothing, 9 times nothing, and 10 times nothing, 11, no, 12, no, 13, no, 14, no, and then I'm back to 15. And then I'm going to list the factors of 100. So 1 times 100, 2 times 50, 3 times nothing, 4 times 25, 5 times 20, 6 times nothing, 7 times nothing, 8 times nothing, 9 times nothing, but 10 times 10. Once I do that, then I can list the common factors, the factors that are on all three lists. The only two numbers that appear on all three lists are 5 and 25. Once I have the common factors listed, then I ask which of those numbers is the greatest value, and that is the greatest common factor. So in this particular number set, the greatest common factor is 25. Let's look at another example of finding the greatest common factor of a set of numbers. In this set, we're going to look at the numbers 10, 18, and 24. In order to find the greatest common factor, I need the individual factors for each number. So first I'm going to list the factors for 10, 1 times 10, 2 times 5, 3 times nothing, 4 times nothing, and then I'm back to 5. Then I'm going to list the factors of 18, 1 times 18, 2 times 9, 3 times 6, 4 times nothing, 5 times nothing, and then I'm back to 6. And then I'm going to list the factors of 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6, and not 5, and then I'm back to 6. Now that I have the individual factors for each number, I want to list the common factors. The two numbers that appear on all three lists are 2 and 3. I cannot use anything else because we don't count the number 1, and the other numbers do not appear on all three lists. And now that I have my common factors, I identify the one with the greatest value, which is the number 3. So let's apply this concept to a real-world scenario. Benny's catering a party. He has 60 celery sticks and 45 small tacos. He wants both kinds of food on each plate. He wants the food distributed evenly. He does not want any food left over. What is the largest number of plates he can use? Or what is the most number of plates he can use? And once he has that number of plates, how many celery sticks and how many tacos will be on each plate? So let's take a look at that. So we are looking at 60 sticks of celery and 45 tacos. Well, I know that he's not going to be able to use more than 45 plates because he doesn't have 60 tacos. So the largest number of plates he can use is going to be 45 or less. But the problem is If he uses 45 plates, he doesn't have enough then to put 2 sticks of celery on each plate. So how can I figure out the number of plates that he's going to use? Well, this is a greatest common factor problem. I need to know what the greatest common factor of 60 and 45 is. In order for me to do that, I'm going to list the factors of each one. So 45, we have 1 times 45, 2 times nothing, 3 times 15, 4 times nothing, 5 times 9, 6 times nothing, 7 times nothing, 8 times nothing. So then I'm back to 9. So those are my 3 factors for 45. Now I'm going to list my factors for 60. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, 7 times nothing, 8 times nothing, 9 times nothing, and then I'm back to 10. Then I'm going to identify the common factors. And the common factors here are 3, 5, and 15. So this tells me the number of plates he could use and not have any food left over. But the problem is asking for the greatest number, or the most number of plates he could use. So he is going to use the greatest common factor, or 15 plates. The second part of the question asks how many of each food item will be on the plates. So if he uses 15 plates, we're then looking for the other factor that goes with 15. So for the tacos, there's 45 tacos. If he uses 15 plates, that means there will be 3 tacos on each plate. And the 60 is the celery stick. So if he uses 15 plates, there will be 4 sticks of celery on each plate. This slide lists some very common mistakes that people make when they are finding greatest common factor. You only need to write the parts in red. You could write more if you'd like, but the parts in red are really the key parts of this particular slide that you'll need to remember how not to find the greatest common factor. So the most common mistake people make when they are asked to find the greatest common factor of a pair or a set of numbers is that they find the multiples instead. People often get greatest common factor and least common multiple confused. So what's important to remember here is that factors are the numbers you multiply together to get the number you're starting with, whereas multiples are the numbers you get when you multiply the number you start with by another number. So you have to think about the number that you're starting with. If you're starting with the number 10, if you are looking for how do I get to 10, that's a factor. If you're looking for what can I do with 10? 10 times what? 10 times this? That's a multiple. So how do I get to a number versus what can I do with a number? So one easy way to remember this is to think about what the words sound like. Factor sounds like fraction, and those are smaller than your starting number. Whereas multiple sounds like multiply, and that means they're larger than your starting number. So that can be very helpful when you're trying to remember what to do. The issue is that people focus on the wrong word. When you're asked to find a greatest common factor, people think about the word greatest and they say, oh, it must be bigger numbers, so I'm going to multiply, my number times 1, my number times 2. Or they see least common multiple and they say, oh, least means small, so I'm going to find, what times what gives me my number. But that's not the word you want to focus on. The important word to focus on is factor or multiple. That will tell you whether you're looking for smaller numbers or bigger numbers, not the words greatest or least. because the words greatest and least, all they do is they tell you which number on the list to work with. They don't tell you how to get the numbers on the list. They tell you what to do with your list once you create it. Now in your notes section, I want you to write down 2 things that you will do to prevent yourself from making this common mistake when you're asked to find the greatest common factor.